The kinetic molecular theory is a theory that explains the state of matter, and it is based on the idea that matter is composed of tiny particles that are always in motion. The theory helps explain observable properties and behavior of solid, liquid, and gases. However, the theory is the most easily understood as it applies to gases, and it is with gases that we will begin our detailed study. The theory applies specifically to a model of gas called an ideal gas. An ideal gas is an imaginary gas whose behavior perfectly fits all the assumptions of the kinetic molecular theory. In reality, gases are not an ideal, but are very close to being so under most everyday conditions. The test of the kinetic molecular theory and its postulate is its ability to explain and describe the behavior of gas. The various gas laws can be derived from the assumption of the kinetic molecular theory, which have led chemists to believe that the assumption of the theory accurately represent the properties of gas molecules.
The kinetic molecular theory is the theory that all matter is made up of atoms and molecules that are always moving. These particles hold kinetic energy and move around in random directions. In higher temperatures, the particles have high energy, and in low temperatures, the particles have less energy. In solids, such as ice, the particles hardly move at all and hold a regular pattern because the energy is low and particles are tightly packed. In liquids, such as water, the particles have more energy and the freedom to move around. Liquids have the ability to flow and fill the shape of any container that are put in. In gases like steam, the particles have the most energy. These particles are sparse and move around freely. Gases are usually invisible to the eye, and they can be expanded and compressed in different pressures. All matter is composed of atoms and molecules that are always moving. The higher the temperature, the more energy these particles have, and that is the kinetic molecular theory. One example of kinetic molecular theory is when you pump air into a tire. The gas molecules inside the tire get compressed and packed close together. This increases the pressure of the gas and it starts to push against the walls of the tire. Helium balloons also experience expansion and contraction with change in surrounding temperature.
Hot air balloons are one of the most unusual aerial vehicles. For a hot air balloon to keep its altitude, as it needs to climb to a higher altitude in order to get the lift it needs and to avoid environmental obstacles. The kinetic molecular theory explains the behavior of gases as the movement of the large number of molecules. So this concept explains why hot air balloons rise. Because the higher the temperature, the lighter the balloon becomes. As the molecules heat up, they move faster and strike the inside wall of the balloon harder. This increases the motion of the gas particles, increases the force of an area of the balloon, producing a rise in pressure.
So in this video, we're gonna do an experiment about kinetic molecular model. So in this experiment, our materials are, we need to have two glasses. We need also a hot water and cold water. And lastly, we need to have a dye colors. Any colors will do. Our procedure, in this glass, we will put here the cold water and this is our glass A. And to this another glass, we will put here the hot water and this is our glass B. After we fill it with the hot and cold water, we will put here the dye colors. In this glass A, we will put the red dye and in this glass B, we will put the green dye. And after that, we will observe carefully the behavior of the color dye in each glass. So let's go, let's do it. The dye mixes through the hot water faster than it mixes with the cold water. This is because in hot water, the water molecules have more energy and are moving faster than the molecules of cold water. This makes it easier for the dye to get mixed throughout the hot water because diffusion happens from high concentration to low concentration. The more molecules are moving, the more opportunities they have to mix together. Diffusion is the mixing of molecules due to the random motion, whether in a liquid or a gas. Because molecules in a cold water has less kinetic energy than in warm water, the diffusion process is much slower than in warm water. The higher temperature, the particles have high energy, and in lower temperature, the particles have less energy. The more energy a particle has, the faster it will move.
Kinetic energy is form of energy that a object or a particle has a result of its motion. Its work, which transfer energy, is done on an object applying a net force. That object is speed up and therefore gains kinetic energy. The example of kinetic energy is moving a car. Moving cars possess some amount of kinetic energy. The second one is bullet from a gun. A bullet from a gun has very high kinetic energy, and so it can easily penetrate any object. The third one is flying airplane. The fourth one is walking and running and cycling, and so forth and so forth.
The gas particles are very apart, which means the mass of a gas is certain value is a very small. As the result of this density, the gas have low densities. We can smell the odor of cooking onions far away because smell the odor of cooking onion is a gas, and the particle of gas move rapidly in a certain lane. As the result, it reach the person who notice its odor.
Gases move faster at higher temperature because at high temperature gases particles have greater kinetic energy. As the result, they move faster at higher temperature. That means that the temperature between gases is directly proportional, which is also said same as decreasing temperature. When it decreases, gas movement will also be decreased and lesser kinetic energy. Gases can be compressed much more than liquids or solids because the distance between the particles of gases are more than they could be pushed closer together and still remain a gas. Furthermore, gases are compressible because most of the volume of a gas is composed of the large amounts of empty space between the gas particles. It is also defined as the relative change in volume of gases with respect to the change in pressure at constant temperature.